Okay, so let's get right into it. How do you teach a computer to really see the world? I'm not talking about just labeling objects in a picture, but to get the context, the nuance, even the absurdity of it all. For years, this has been one of the biggest puzzles in AI, but a new model is completely changing the game.
To really get what I'm talking about, let's try a little magic trick, something straight from the research paper. Imagine you're just chatting with an AI, and you don't show it a cat or a dog or something simple. You show it something totally bizarre, a picture you just made up.
And you just state the facts, right? This is a picture of two teddy bears on the moon. Then you start a conversation, just like you would with a person. You ask, what are they doing? The AI says, they are having a conversation. Okay, interesting. What object are they using? The AI comes back with, it looks like a computer.
But this is where it gets absolutely mind-blowing. The researchers ask it, why is this picture surprising to you? And the AI gives this response. It doesn't just describe the pixels on the screen, it understands the implication. It gets the joke. That level of reasoning from just looking at a picture is a massive, massive leap forward.
So who's the magician behind the curtain? Well, this is Flamingo, a new visual language model from the folks at DeepMind. And the way it learns is what makes it so revolutionary. But to really appreciate its genius, we first have to talk about the old way of doing things.
Yeah, before Flamingo, if you wanted to teach an AI a new visual trick, it was all about brute force and just an unbelievable amount of data. Think about it. For every single new task, whether you wanted it to identify different dog breeds, describe what's happening in a video, or answer questions about a city street, you had to start this long, expensive training process pretty much from scratch. It was a huge bottleneck.
This whole process is called fine-tuning, and it needs a mountain of labeled examples. We're talking thousands, sometimes hundreds of thousands of pictures, all carefully annotated, just for that one job. It's incredibly expensive. And the worst part? The model you get at the end can only do that one specific thing.
And this slide, well, it really lays out the difference. On one side, you've got the old way, fine-tuning. It's slow, it's expensive, and it's totally inflexible. But on the other side, you have Flamingo's approach, few-shot learning. It's kind of like the difference between cramming a textbook for one specific test versus actually learning how to learn, so you can ace any test. Flamingo can pick up a new skill with just a handful of examples.
All right, so what's the secret sauce? How does Flamingo actually pull this off? Let's break down the clever architecture that makes it so different.
The secret isn't building some brand new giant model from the ground up. Nope, it's all about standing on the shoulders of giants. Flamingo very cleverly connects two massive pre-existing AI models that are already total experts at what they do.
So first, it takes a cutting-edge vision model. You can think of this as the eyes. It's already been trained on billions of images, so it's an expert at just perceiving visual stuff and turning it into data that a computer can work with.
Then it brings in a massive large language model. This is the brain. It's an expert at understanding and generating text, spotting patterns, and doing a kind of basic reasoning based on all the text it's learned from.
And here is the really elegant trick. Instead of retraining the eyes or the brain, which could actually make them forget what they were good at in the first place, a huge problem in AI called catastrophic forgetting, it's like teaching a chess grandmaster how to play checkers, only for them to forget how to play chess. So Flamingo just freezes them. It locks all that knowledge in place. Then it adds these brand new lightweight layers between them. This clever bridge is the only part that gets trained, and its entire job is just to translate what the eyes see into something the brain can think about.
So that's the theory. Sounds great on paper, right? But does it actually work in the real world? Well, the researchers put Flamingo through an absolute gauntlet of 16 different visual tests to see how it stacked up against the competition.
And the results, they're honestly just staggering. What you're seeing here is Flamingo's performance compared to the previous best-in-class models, the ones that were fine-tuned with thousands and thousands of examples for each task. With just 32 examples, Flamingo doesn't just keep up. On a lot of these tasks, it completely blows the old method out of the water.
Let's just let this number sink in for a second. 6. On 6 of these 16 really tough benchmarks, a single Flamingo model, after being shown just 32 examples, set a brand new state-of-the-art record. It beats specialized models that were force-fed orders of magnitude more data. That is efficiency on a completely different level. Okay, so it's fast, it's efficient, it breaks records. Cool. But so what? Why does this actually matter for the future of AI?
Well, for starters, it means we can have AI systems that adapt to new visual challenges in minutes, not months. This lowers the barrier to entry, right? You don't need a Google-sized dataset anymore to build a really useful application. We're moving away from these one-trick pony models and toward much more flexible, general-purpose AIs that can start to understand our world in a much more complete way.
Ultimately, if there's one thing you should take away from all this, it's that the ability to learn from just a few examples is a huge deal. It shows that AI is becoming less about brute force data and more about efficient, flexible intelligence. It's basically learning how to learn, and that's a major step forward.
And that leaves us with this big, kind of wild question to think about. We've seen what happens when AI masters language. But what happens to our world when an AI can learn to see and understand pretty much any visual task we throw at it in a flash? The possibilities are really just starting to come into focus.